So last class we discussed about the reabsorption in the proximal convoluted tubule, and we also discussed about the secretion. So these are the molecules which will get secreted into the proximal convoluted tubule. So I also discussed about the different metabolites which will get secreted, including the drugs and toxins. So today we are going to discuss about the which one? This one, what is that? Loop of Henle, descending loop of Henle, and as well as ascending loop of Henle and distal convoluted tubule. Mute, please, mute. So now just to go through this particular diagram. This is descending loop of Henle, and this is a loop, hairpin loop, and this is ascending loop of Henle. And you can see that the cells of loop of Henle is quite different from proximal convoluted tubule. Reason is, it doesn't contain sodium potassium ATPase, and if sodium potassium ATPase is there, you require a lot of amount of energy and you require a lot of mitochondria. So here that means sodium potassium ATPase is not existing here in this loop. And when it is not existing, then energy is not required. So cells are quite different in the loop of Henle. So that is not the only difference. There is something else about this loop of Henle. This descending loop of Henle, it will allow only water. It will allow only water to get reabsorbed. That means water can move freely through descending loop of Henle. And ascending loop of Henle, I'm talking about only thin ascending loop of Henle. It will not allow the water reabsorption. This is not watertight, and this is watertight. So that means the water move freely from the tube to the interstitial fluid in descending loop of Henle. Whereas in case of ascending loop of Henle, water cannot move from the ascending loop of Henle. Then why I'm stressing this particular point? So for that, you have to understand one more concept here. You just go through this particular diagram. See here, we are going to totally different concept now. For example, you heard about the body fluid and as well as osmolarity of the body fluid. That means number of solutes present in a given solvent in the body. Any fluid you take is approximately, that means range is there. So to be specific, it is 292 millimoles per liter. I repeat again, 292 millimoles per liter. This is the concentration of the solute in a solvent in our body fluid. Whether it is a blood or any fluid you take, it should be 292 millimoles per liter. Then milliosmol per liter. Then similarly, we are considering that 300 is the range. That means instead of 292, we are talking that it is a 300. So when the blood fluid, for example, the filtrate also, its osmolarity is 300. When it comes to proximal convoluted tubule, that time also it is 300. But once it starts to move towards the descending loop of Henle in the tubular region, you can see that the osmolarity of the fluid becomes 400, 600, 900 and reaches the 1200. So why it happens like that? The reason is up to this extent, that means up to proximal convoluted tubule, the amount of the solute and amount of the solvent. Solvent in sense, we are talking about water. So both reabsorption is same. That means how much amount of solute is reabsorbed, the equal amount of solvent also will get reabsorbed. Water also will get reabsorbed up to proximal convoluted tubule. But once it comes to the descending loop of Henle, what happens? Only solutes are moving, only water is moving, but solutes are not moving outside. That means only water is moving outside from the tube. Once the water moving out of the tube, then automatically the concentration of the solute increases in the descending loop of Henle. So you can see that here water is moving out, and thereby the osmolarity in the descending loop of Henle, it becomes 400. That means the concentration of the solute in the solvent becomes more. Then when it moves this extent, further water is moving out, and then the concentration of the solute further increases. And when it comes to what you can say, deep of the thin loop of Henle, then lot of amount of water is moving out and the concentration of the solute becomes 900. And when it comes to the hairpin, the concentration of the solute becomes 1200. That means you can understand that. So up to this extent, both solutes and water is moving out in the proximal convoluted tubule. Once it comes to the descending loop of Henle, only reabsorption of water is there and reabsorption of solute is not there. So that's why the concentration of the solute becomes 1200 here. Then once the fluid moves towards the upper, that means here you can see that ascending loop of Henle. This is thin ascending loop of Henle. When it moves to the thin ascending loop of Henle, interestingly, the water cannot be reabsorbed. Only solute is moving out, but the water is not moving out. So thereby solute continuously it is moving out, and water is not allowed to get reabsorbed. That's why the osmolarity becomes 200 here, interestingly. So that means the osmolarity of the tubular fluid in the loop of Henle, that is descending loop of Henle, so it becomes hyperosmolar. Hyperosmolar, that means more amount of solute is present in the fluid compared to water. Once it goes towards the upper, what I can say, ascending loop of Henle, thin ascending loop of Henle, it becomes hypoosmolar. Why? Because the water is not allowed to get reabsorbed here, only solute is getting reabsorbed here. So this is called counter current concept. That means initially it is water is reabsorbed in the descending loop of Henle, and once it moves towards the ascending loop of Henle, water is not allowed, only solutes are allowed. So thereby the osmolarity get decreased and amount of water becomes increased in the tubular fluid. This is about the descending loop of Henle and as well as ascending loop of Henle. Which ascending loop of Henle? In ascending loop of Henle. So this is called a counter current method here. Then next what happens, the fluid starts to move towards the which one? Thick ascending loop of Henle. So let us concentrate on thick ascending loop of Henle. Repeat again. So this concept you try to understand again. The body fluids, that means in the body fluid, the amount of the solute present in the body fluid. So that we call it as osmolarity. So here the normal osmolarity of the human body, that means any fluid, is 292 milliosmol per liter. So that means it should be the ideal concentration. It should not be more or it should not be less. To maintain that one, kidney is required. So the blood is moving here and then it will get filtered. That time, consider instead of 292, consider we are talking about 300. Consider it is 300. So thereby calculation becomes easy. 300 milliosmol per liter. Then once the filtration starts and then reabsorption starts, and still it is 300 milliosmol. Why? Because the amount of the solvent, that is water, the amount of the solute, that is sodium, potassium, calcium, magnesium, glucose, etc., which get reabsorbed in the proximal convoluted tubule are same. So that's why still it is 300 milliosmol per liter in proximal convoluted tubule. So the whatever the filtrate is there, tubular fluid, once it starts to move towards the descending loop of Henle, here the solutes are not getting reabsorbed. Only water is coming out in the, what I can say, descending loop of Henle. Only water is coming out means, so the solute concentration in the descending loop of Henle will increase and water content will decrease. Why? Because water is reabsorbed rapidly here. So that's why the concentration of the solute in a given solvent increases. Remember, the solvent, the solute will be same. Amount of solute, for example, 5 grams of solute is there. The concentration of solute will be same throughout this particular tube. But the point is, the amount of water present in this particular tubular fluid will get decreased here. That is descending loop of Henle. Constantly water is moving out. The concentration of the solute increases. So thereby, it becomes 400 milliosmol per liter in what you can say in the thin ascending loop of Henle. As it comes down, more amount of water is getting reabsorbed. Thereby the concentration solute will get increased like anything. Once it reaches the hairpin, this particular area, it becomes 1200 milliosmol per liter. But interestingly, what happened once the filtrates start to move towards the thin ascending loop of Henle, this is the thin ascending loop of Henle, when it starts to move, and the cell structure of thin ascending loop of Henle is different compared to what I can say descending loop of Henle. It will not allow the water to get reabsorbed. Only solutes are getting reabsorbed here. So thereby what happens? So water will be retained in the tube and solute starts to move out of this particular tube. So thereby again the osmolarity of this particular fluid reaches 400, and finally so much amount of what I can say solutes are reabsorbed, it becomes 200 in the thin ascending loop of Henle. From here thick ascending loop of Henle will start. Are able to understand or not? So to maintain this osmolarity, so this concept, that means while descending loop of Henle, loss of solutes are there. Ascending loop of Henle, descending loop of Henle, loss of water is there. Ascending loop of Henle, loss of what you can say reabsorption of solute will be there. That means here water is reabsorbed more, here solutes are reabsorbed. So it is compensating mechanism. This is called counter current method. This mechanism is necessary, very much important. So that's why this loops allows makes this particular concept. That means this concentration like this. If it is not a loop structure, consider if it is a straight line structure, continuously tube is there, then definitely this concept it does not exist. It will not exist because it is the loop. So a lot of amount of solutes will get accumulated here because whatever the solutes which are coming out here, it is reabsorbed. Everything starts to get accumulated here. So that's why the concentration, you can see that this is the interstitial fluid. So interstitial fluid here, initially it is 300, it becomes 400, 600, 900, 1200. As the cortical region, the osmolarity will be 300. In the medullary region, the osmolarity will be 1200. So now the filtrate starts to move towards the ascending loop of Henle. Now it is ascending loop of Henle we are going to discuss here. So this is thick ascending loop of Henle. Thin ascending loop of Henle is over. This is thick ascending loop of Henle. Little complicated. You just concentrate on the diagram, then you can understand very easily. As usual, same. Sodium, potassium, ATPase is there. Remember, descending loop of Henle and thin ascending loop of Henle does not contain sodium, potassium, ATPase. But once it is thick ascending loop of Henle, then again sodium, potassium, ATPase is there. That means it requires lot of amount of energy and it requires sodium. So it requires the sodium to, what you can say, throw out this particular sodium which is present in the cell to which one? Interstitial fluid. So many sodium, potassium, ATPase is there. Till now, we have not discussed anything about from where the sodium, potassium, ATPase is coming. That we will discuss at the end. So how it is synthesized, how it is present in this particular basolateral membrane, that we have not discussed anything. Later on, we are going to discuss anyhow at the end. Now you see this apical membrane of the which one? Thick ascending loop of Henle. Here one specialized transporter is there. You can see that sodium, potassium and 2 chloride. That means simultaneously this particular transporter, it will transport 1 sodium, 1 potassium and 2 chlorides. At a stretch it will transfer from the tubular fluid to which one? Cell. Which cell? Thick ascending loop of Henle cell. So all this sodium, potassium and chloride is moving inside the cell. It is a transporter, very important and interesting transporter. So why it is important means approximately 25% of sodium will get reabsorbed in this particular area. Remember, already we discussed in the proximal convoluted tubule, water and sodium, 65% of sodium and water will get reabsorbed in the proximal convoluted tubule. Here, it is approximately 25% of sodium will get reabsorbed here. So along with the potassium and chloride. Fine. Now the sodium is there and sodium will get reabsorbed. That means it will move out of the cell into the which one? Blood vessel, and then potassium is coming inside. But here some issues are there. If you observe carefully, this potassium is moving from, what you can say, it is moving inside the cell here. For every sodium, potassium is moving. And apart from that, potassium from the tubular fluid, it is also moving into the cell. Are you able to understand? Potassium in exchange with the sodium, it is moving inside the cell here because of the sodium potassium ATPase. Along with this, potassium also moving along with the sodium and as well as chloride here. So that means the concentration of the potassium becomes too much inside the cell. So heavy potassium content will be present in the which one? Proximal convoluted tubule cell. Now that much amount of potassium cannot be handled by the cell. What the cell is having a mechanism. It is having some leakage channels. You can see this is one leakage channel. This is one leakage channel. The potassium which gets accumulated inside the cell, it will get leaked out from the cell, outside the cell into the interstitial fluid. And then some amount of the potassium will move outside the, which one? Into the, it will go inside the tubular fluid again. Again, it will go back to the tubular fluid. That means what? The concentration of the potassium in the tubular fluid in a thick ascending loop of Henle will become more. I repeat again. Potassium is moving inside the cell. Here also potassium is moving inside the cell. The concentration of the potassium becomes too much inside the cell. And that much amount of potassium is not necessary for the cell. What cell will have a separate mechanism? It is having a leakage channel here. The potassium will get leaked out of the cell into the interstitial fluid. And the potassium also will go back into the tubular fluid. So the potassium is moving into the tubular fluid again. So thereby what happens? Sodium is moving inside the cell and chloride also is going outside. And the concentration of the potassium in the tubular fluid will become very high, abnormally high. How much high means the tubular fluid concentration, that means the charge of the tubular fluid becomes 8 millivolts. That means that much amount of potassium gets accumulated in the tubular fluid. Now, because of this, what is the problem? Anything is interesting is happening here. Yeah, something interesting is happening. I already told you that in the filtrate, that means in the starting in the glomerular filtration, the filtrate also contains calcium and as well as magnesium. Till now, we have not discussed anything about calcium and magnesium. So quietly, the calcium and the magnesium is traveling in the tubular fluid. Once it reaches the proximal, loop of Henle, thick loop of Henle, here the charge is so positive. It is so positive here because of the potassium. I told you that it is approximately 8 millivolts. Further, this is a monovalent cation. Which one? Potassium is monovalent, whereas calcium and magnesium is divalent. So this potassium, what it will do? It will not allow this calcium and magnesium to come forward because already the charge is too positive in this particular area. So what this potassium will do? It will block the entry of this calcium and magnesium, and then it will try to kick out this calcium and magnesium from the tubular fluid. Then calcium and magnesium both, it will move out of the tubular fluid between the cell. This is one cell and this is another cell. Between the gap between the cell, the calcium and the magnesium will move out of this particular cell. That means out of the tubular fluid. Remember, this is also reabsorption. But this generally what we studied in hormone, the reabsorption of the calcium is promoted by the parathyroid hormone. But here you cannot see any parathyroid hormone here. So that means here the calcium and magnesium reabsorption is nowhere concerned with the parathyroid hormone. This reabsorption of calcium and magnesium purely because too much amount of positivity or too much amount of potassium is present in this particular tubular fluid. It will not allow the further movement of calcium magnesium. That's why it will try maximum to throw out this calcium and magnesium out of this particular tubular fluid. Don't think that 100% calcium and magnesium will be thrown out. Some portion of calcium and magnesium will be thrown out of the cell through what I can say cells between these two cells. I think you understand the concept here. And then still some amount of calcium and magnesium will be there. This is what is happening inside the thick ascending loop of Henle. Remember, we are talking about thick ascending loop of Henle cell. So what we discussed, just fast I will review this one. So thick ascending loop of Henle contains a transporter called sodium potassium 2 chloride cotransporter. It will transport sodium, potassium and chloride from the tubular fluid into the cell, and sodium will get reabsorbed with the help of sodium potassium ATPase. Chloride will remain inside the cell, and the potassium is moving inside the cell, and from which one? Apical membrane. It is also moving inside the cell through basolateral membrane. So the potassium concentration inside the cell become too much. It cannot be handled by the cell. So that's why potassium will be thrown out of the cell by leakage channel into the apical membrane. So this leakage channel, it will allow the potassium move into the tubular fluid, and this particular potassium leakage channel, it will allow the potassium to leak out into the interstitial fluid. The potassium which enters into the tubular fluid, again, it will increases the concentration of this potassium ion concentration in the tubular fluid. It becomes too positive. That means approximately 8 millivolts. Because of the high positivity, whatever the calcium and magnesium is coming into the tubular fluid, which is moving in the tubular fluid, it will not be allowed further. This potassium will kick out this calcium and magnesium. So out of the tubular fluid into the interstitial fluid between the cell, not inside the cell. You can see that it is not entering inside the cell. Between the cell, the calcium and magnesium are kicked off. And most important point you have to remember, this mechanism is nothing to do with the parathyroid hormone. It is independent of parathyroid hormone. Calcium absorption and magnesium absorption in thick ascending loop of Henle is due to the excess concentration of potassium, and then the potassium will kick out this calcium and magnesium out of the tubular fluid. This is what about the thick ascending loop of Henle. This is the mechanism. Now the tubular fluid from here. One more thing I forgot. This is not required examination point of view, but you have to remember actually. Next semester it will be very useful for you. This transporter is something special here. For example, a person is suffering from high blood pressure, or for example, excess amount of fluid is there, or for example, too much amount of calcium is present in the blood. Then what the doctors will prescribe? they will prescribe one diuretic. Heard about diuretic, everybody? Have you heard about diuretic? Have you heard about diuretic? Yeah, they will prescribe diuretic. They prescribe diuretics, particularly one type of diuretic called as loop of Henle diuretic. It's called as loop diuretic. What that loop diuretic example is, one particular name I will tell you, furosemide. If in future it will be useful. That furosemide, what it will do, if you consume that particular drug, it will block this particular transport. I repeat again. So person who is suffering from very high blood pressure, too much amount of water content in the body, and too much amount of what I can say sodium present in the body, or too much amount of calcium or something present in the body. In such cases, they will prescribe a drug called loop of Henle diuretics. Example is furosemide. That furosemide, it will block this particular which one transport. If it blocks the transporter, what will happen? Sodium cannot be absorbed, potassium cannot be absorbed, chloride cannot be absorbed. So everything will get excreted out along with the water. So this is how you can reduce, that means you can eliminate excess amount of sodium, potassium, chloride, calcium, etc. etc. But is it a correct mode of treatment? Is it a logical or, for example, systematic treatment? That question don't ask. Okay, it depends on the patient. So don't come to conclusion it is a fantastic treatment. It is having its own disadvantage. If you use your brain properly, then you can understand that there is some huge disadvantages there in the usage of this particular diuretic. And it is a powerful diuretic. Loop of Henle diuretics are powerful diuretic. We already told you that 25% of the sodium will get reabsorbed here. So that means you are not allowing, by using that particular drug, you are not allowing the reabsorption of 25% of the sodium here. So that means 25% of the sodium will get excreted out from the body. It's a huge quantity. It's not a small quantity. I think you understand the concept. In future, in pharmacology, you are going to study about that concept here. So it is having its disadvantage. Now you think logically. Now you have to think what I can say logic concept, logic point of view. Consider a person is there who consumed a diuretic which blocks this particular transporter. That means sodium cannot be absorbed, potassium cannot be reabsorbed, chloride cannot be reabsorbed. If sodium, potassium, chloride cannot be reabsorbed, then potassium cannot move inside. That means when they are not moving inside, there is no use of this particular sodium potassium ATPase. This also will stop because sodium is not coming inside. Means what is the work with the sodium potassium ATPase? This also stop to work, and this stops work means potassium also cannot get inside the cell. When potassium is not entering inside the cell, then there is no point in talking about potassium again coming back into the tubular fluid. That means what? So the tubular fluid will not be highly positive. It will not be highly positive. Then there is no question of talking about potassium kicking out this calcium and magnesium from the tubular fluid. That means all these things, sodium, potassium, chloride, calcium, magnesium, everything will remain inside the tubular fluid. So all these things will get eliminated from the body in the urine. That means what is the advantage? Advantage is simple. You are eliminating sodium and as well as water, thereby your blood BP may come down. But what is the disadvantage? You may experience a huge loss of calcium and magnesium. So a person, it may be useful in see here dually how to think. A person, what actually the problem is? Problem is blood pressure, then it works out. No, the problem is excess amount of calcium in the blood. It works fantastically. Consider a person who is suffering from high blood pressure and you are using this particular drug called as furosemide. Then you will have a disadvantage that calcium will get eliminated from the body, which is not required for you. You want only sodium to get eliminated, but not calcium. But loss of calcium also will be there. Then what you have to understand, whenever you are using loop diuretics to control the blood pressure, etc., then you experience huge loss of calcium. So that means consider a person with high blood pressure and as well as what I can say suffering from like arthritis, osteoporosis or something. Then if you prescribe this drug which blocks this particular transporter, then that person, it causes severe damage. That means further the arthritis will get aggravated because lot of amount of calcium will get eliminated from the body. So when you want to prescribe, that means when a doctor want to prescribe this group of drugs, that means loop diuretics, he should be very careful. He should be aware that not only it promotes the excretion of sodium, potassium, chloride, it also promotes the excretion of calcium. So the physician should be very careful in prescribing this drug. It is a very popular diuretic. Loop diuretics are very popular. I think you understand. So that's why I told you that. So we cannot come to conclusion that whether it is correct or wrong to prescribe that particular drug. Depending on the patient, we can prescribe. For example, in case of obese patient, so sometimes they may prescribe this particular diuretic. So it is like that you can question it. That means whether it is correct or wrong, you have to go for detailed study. Individually, you have to study. Then only we can understand whether it is correct or wrong. So next, this is the what I can say, distal convoluted tubule. Remember early distal convoluted tubule. So I am discussing the distal convoluted tubule in two parts: early distal convoluted tubule, late distal convoluted tubule. This is early distal convoluted tubule. The reason is there. Why I am discussing the distal convoluted tubule in two parts? You can understand very carefully. You try to understand. Now, first, this is early distal convoluted tubule. Now, for example, as usual, you can see that this is something unique, totally different. You can see that sodium potassium ATPase is there as usual. You can see here sodium potassium ATPase. Obviously, you require ATP. You require a lot of amount of energy. So when sodium potassium ATPase is there, it is understood that sodium should enter inside the cell from the tubular fluid. It is compulsory. But here the transporter is different. You can see that sodium and as well as chloride is entering inside the cell with the help of one transporter. This transporter is called as sodium chloride co-transporter. So what is interesting is sodium gets reabsorbed every time with a different company. So in the proximal convoluted tubule, it is with the glucose, amino acid, chloride, etc., etc. Then again in the thick ascending loop of Henle, it is having a company with some other. For example, we already discussed that it is sodium, potassium, 2-chloride co-transporter. Now, if you come to early distal convoluted tubule, the company is different. Sodium, chloride co-transporter. Then sodium enters and as well as chloride enters. It is this early part of distal convoluted tubule. It is very interesting here. So many transporters, etc. channels are there. And apart from that, along with sodium chloride co-transporter, one more channel is there. That is called calcium channel. That means this calcium channel, it will allow the movement of the calcium continuously. That means calcium is there. So in the tubular fluid, it enters inside the cell, this calcium. Once it enters inside the cell, which one? Calcium enters inside the cell. It is having two options. That means not a single option. It is having a multiple option. Two options are there to move out of the cell. I repeat again, calcium which is present in the tubular fluid, it enters into the cell with the help of which channel? Calcium channel. Once it enters into it enters inside the cell. So once it enters into the cell, it should move out of the cell. To move out of the cell into the interstitial fluid, it is having two options. Option number one. Here you can see one transporter is there. This is called as calcium ATPase transporter. This is not ATPase transporter. That's just calcium channel to enter inside the cell. To move out of the cell, it requires one particular transporter that is called as calcium ATPase transporter. With the help of this transporter, the calcium moves out of the cell into the interstitial fluid and then it will get reabsorbed. Apart from that, calcium is having another option. It moves out of the cell into the interstitial fluid. So with the help of sodium, that means for every calcium which is moving out of the cell, a sodium will enter inside the cell from the interstitial fluid. So it is a cycle. That means continuously calcium is moving out of the cell into the interstitial fluid and continuously sodium is entering inside the cell. So finally, what I am trying to tell, calcium enters to the cell through calcium channel and then it moves out of the cell with the help of calcium ATPase transporter, and along with that, calcium also can move out of the cell with the help of calcium sodium antiport. We are supposed to call it as antiport because it is not moving in same direction. It is moving in opposite direction. So calcium is moving in this direction, sodium is coming in opposite direction. So that's why we cannot call it as co-transporter. We are supposed to call it as antiport. So finally, calcium is moving out. But here the calcium movement, that means whether you talk about calcium channel or calcium ATPase transporter or calcium sodium antiport, so all these things are promoted by the hormone called as parathyroid hormone. So here the calcium reabsorption is promoted by the parathyroid hormone. Earlier what we discussed in the thick ascending loop of Henle, it is nothing to do with the parathyroid hormone, but here it is because of parathyroid hormone. That means always this parathyroid hormone will be present here in the kidney. No, it will not be present. Only when the calcium content, for example, in the blood, calcium levels, if it is low, repeat again, when in the blood, the calcium levels are very low, then the parathyroid hormone will get activated and it will promote the reabsorption of calcium in this particular area. And apart from that, anything interesting is there? Yeah, it is there. So for example, I have written thiazide. This is also not required to write in the examination, but you have to remember next semester you are going to study in pharmacology. Some group of drugs are there, like diuretics again. This is one variety of the diuretic, thiazide. And this thiazide, what it will do, it will block or it will inhibit the sodium chloride co-transporter. By blocking this sodium chloride co-transporter, so sodium and chloride will get eliminated from the body. Remember, it is not disturbing the calcium. It is disturbing only sodium and chloride. But actually, one thing you have to understand, 65% of the sodium is reabsorbed in proximal convoluted tubule. 25% is reabsorbed in the thick loop of Henle, thick ascending loop of Henle. 65 plus 25, 70, 90. Approximately some 5% of sodium will get reabsorbed in this particular area. Which area? The early part of distal convoluted tubule. That means if you consume this diuretic, only 5% of the sodium can be eliminated from the body. Not like earlier I told 25%. It is only eliminating 5%. It is promoting the elimination of sodium 5%. So that means you have to understand earlier what diuretic we discussed. Loop diuretic, loop of Henle diuretics or loop diuretics. Example, furosemide. So if you compare that diuretic with this diuretic, this is a weak diuretic, that is a strong diuretic, because it is eliminating 25% of the sodium and water. And but this one, it is eliminating only 5% of sodium and as well as water. So comparatively, thiazides are weaker diuretics. So when the issue or the problem is not that much severe, consider a patient with some issues are there. We have to give some diuretics and the person is suffering from arthritis, then this is the best drug. Why? Because it is not causing the loss of calcium. It will prevent the loss of calcium. So that's why it is a better bet. But if a patient is suffering from high levels of calcium, is unable to eliminate this calcium, then loop diuretics, what we discussed in the upper thick ascending loop of Henle, that is a better. Some people genetically, what happens, they suffer from, you heard about stones, kidney stones. Have you heard about kidney stones? Calcium oxalate crystals will be there. Partly it is genetical. Some people, if you think that we are eliminating a lot of amount of calcium, you are moving the calcium from this area, but there is no guarantee that all these calciums will get eliminated from the body. They may form crystals in the other part of the kidney, like we discussed about the uh, collecting tubule, or for example in the ureter or some other area, the calcium, excess amount of the calcium which is moving, they may form some crystals, calcium oxalate crystals. Then further it will complicate the problem. So there is no advantage here, there is no disadvantage here, depending on the patient. So we can recommend loop diuretic, or we may recommend thiazides. No, you want huge loss of potassium, consider huge loss of sodium you want to eliminate from the body, then this will also will not work out. And last one, which one? Loop diuretics, that also will not work out. Some other diuretics are there. For example, acetazolamide, one particular drug is there that will target in the proximal convoluted tubule. Like that, depending on the patient, so you have to select some particular drug. So thereby safely the ions should be eliminated. Why? Why? Because at any cost, you have to maintain what I told you, osmolarity, that is 300 milliosmol per liter, that you have to maintain. So if you are unable to fail to maintain that one, then it becomes a serious issue. So whether you use any drug, if your kidney is functioning or whatever it may be, so it should maintain that 300 milliosmol per liter, then only it will work out. So this is about the which one, reabsorption in the early part of distal convoluted tubule. Any questions are there? You can ask fast. Any questions are there? You can ask now. Yeah, anybody? Any questions? Yeah, within some 15-20 minutes again I will call you for meeting. Are you ready to come? I want to wind up today this topic. Are you able to hear? Fast.
Yes, sir.
Yes,
Fine.
sir.
Yes,
Those
sir.
who are interested, they can come back. Within, I'm going to post again what time. Just within 5 minutes, I will post what time you have to come back. Okay.
Okay,
Okay,
sir.
sir.
Okay.
Okay, sir.